Kia ora koutou katoa. Welcome everybody. Hope you're keeping well. Challenging circumstances. Just a couple of comments from me. We were COVIDed that prevented us from having the presentation a month or so ago, and happily through ITA Working Group 5 colleague Francois and his colleagues at Pinssar, they've agreed to give us this presentation. So very grateful. It's a bit of a first for us, this online format. I hope it works for everybody. Be happy to get your feedback on it. So unfortunately, it seems as if we won't be able to schedule the person-to-person event that we're planning for the GBRs in about a month's time, but we have an alternative lined up in the form of a presentation from Maxwell Geosystems. They do cutting-edge instrumentation and integration of the same for projects like the deep tunnel sewage scheme in Singapore and HS2 in the UK. So that should be quite interesting. But as Holly says, and back to this one, any questions that you have, just jot them down as we go. We won't answer them as we go, but at the end of the presentation, we'll hope to address as many of them as we can. So without further ado, I'd like to hand over to Mr. Daniel Rose of Pinssar to take us through the presentation this evening. Thank you.
Thank you, Bill, and thank you, Holly. Greatly appreciate this opportunity. Hopefully someday we'll be able to travel again and get back over to New Zealand. We're based in Brisbane, and with me today we've got Francois Velge, who's the MD of Pinssar, and Wayne Hose, who's the Business Development Manager International, and myself, Business Development Manager Australasia. So thank you everyone for attending today. I'll jump into the slideshow. Okay, so we'll talk a little bit today, like the flyer said, about air quality and advancements in DPM monitoring and the differences between dust and DPM. But essentially, diesel is quite prevalent in tunnelling and any underground excavation activities, such as mining as well. And the message that we like to say is that diesel emissions can be managed safely. We'll talk you through the technology that Pinssar has come up with in the following slides. Certainly there's been a lot of talk, and will continue to be a lot of talk around more and more electric equipment coming into the industry, and Pinssar certainly welcomes that. But at the same token, we also acknowledge that that's going to take quite some time to get up to 100%, and may never get there. There might just be some special ancillary equipment that will never go that way. So what the message is we really need to manage the risks and threats today in the move towards electrification. So like the flyer said, the DPM awareness is growing, and we had a couple of statements there from a couple of bodies internationally. One, the British Occupational Health and Safety, that published figures saying that of 100 work-related deaths, 99 can be attributed to occupational illnesses. So what that's saying is that the industry is doing a very good job on safety and those incidents that can happen immediately, but there's still a lot of work to be done in the health side of things to bring those numbers down. And then another quote there from the Australian Cancer Council. They've published that DPM, diesel particulate matter, or diesel exhaust emissions, is the second most common cancer-causing agent in Australia, only behind ultraviolet radiation. So obviously, when you're working underground, you don't get exposed to the sun. So therefore, yeah, working underground, DPM is the #1 cancer-causing agent in the workforce for underground workers. I'm sure that's very similar for operations around the world. So if we just talk about the threats of DPM, certainly the awareness of air quality has grown in the underground space, and particularly in dust and crystalline silica. But also DPM is certainly just as an equal a risk, and what we need to do is become more aware of it as an industry. This just sort of shows the difference between the two, but more importantly, the size compared to a fine beach sand and a cross section of a hair. You can see there the PM10, the blue dots, and that's your pollen, that type of stuff. And you can see the pink on those blue, which is your traditional dust particles that we monitor, PM 2.5 and under. And then you can see some tiny black dots on those pink dots. That's representative of DPM. So again, quite smaller than the dust that we're monitoring. Comes in under 0.8 of a micron, or 800 nanometers, and is invisible to the naked eye. So very, very small. And how that affects health, as you can see there, in 2012, the World Health Organization declared DPM as a Group 1 carcinogen, same risk category as asbestos. And you can see there in that picture that the dust particles that, rightly so, are getting a lot of attention underground recently. They get caught in the human's natural filtering system, the lungs being the worst case, and that's where potential for crystalline silicosis can occur. But if you see to the right of that, the even smaller particles being DPM go through all those natural filtering systems of the throat and the nasal passage in the lungs, and directly into the bloodstream. Now you're talking about carcinogenic material getting straight into the bloodstream. That certainly is not what we're here to achieve. So having awareness of your DPM loads, and then making adjustments to your controls to bring those loads down, that's certainly the best way to manage DPM. So this graphic just shows how DPM behaves and in terms of size. So on the bottom axis here, this isn't linear. You can see here's 1 micron or 1,000 nanometers, and that's above. So that's generally where the dust particles will sit. And then below 800 is generally where the DPM will sit. So when the DPM is first comes out of the exhaust, the number or the particle count is very high. Lots of very, very small, under 10 nanometer and just over 10 nanometer nanometer particles. But as it hits the atmosphere, what the DPM particles do is they agglomerate. So they find each other and quickly stick to each other. So this peak is as it's coming out of the combustion process. Once it hits the atmosphere and starts to cool, they agglomerate. So the number of particles goes down because they're now joining together. But what happens is the mass and the surface of these particles increase. So we're still talking about very, very small particles, still well under 1 micron. But that's where the workplace sees DPM in that atmospheric conditions. So that the monitor that Pinssar have developed specifically is built from the ground up to that range, to look at that range, and the peak accuracy, or where we focus the laser, is in that that zone where the mass is at its peak. Most dust monitors, or in fact, all dust monitors, rightly so, focus on that sort of around about 1 and above. Their range can come down to around about 700, but as you can see, they're not hitting the zone that you need to for DPM. So there is some misconception out there that you can monitor DPM with dust monitors. Some can be fitted with devices to make that happen. But in terms of continuously monitoring DPM, there isn't anything else available other than the Pinssar that's been developed. So very quick shot of where Pinssar started, and it was around 2012, just after the World Health Organization declared DPM a Group 1 carcinogenic. Francois, the managing director here, he was working underground, writing diesel management plans, and got the question from a mine manager to say, okay, well, we've got these plans in place, we're spending a lot of money, but how do we know that these mitigating devices such as filters and ventilation, how do we know that that's working? And Francois said, well, you measure it. And he said, that's all good and well, but there's nothing I can find that can measure it on a continual basis. So that started Francois's journey off. He went researched and came to the same conclusion, and then decided to partner up with a guy called Peter Knott, who's a very well respected hygienist in the industry here, and try and come up with a unit that would measure that, which took quite a substantial time. And part of that journey was getting in front of mines and tunnelling operators and understanding if they were going to design something like this, what would be required. And the number one constant that came back was low maintenance and reliability. Don't want to be having to maintain these units on a regular basis. So fast forward to 2018, that was commercialised, and these days we've now patented with 23 unique innovations. So the Pinssar system, it consists of two things. Basically the sampler, or the reader as we call it, and then the dashboard. So the sampler goes underground. It's the robust, low maintenance piece of equipment, and the dashboard is very configurable. It can go on laptop, iPhone, through your SCADA system into your control system. So there's the reader there, and there's the dashboard. So just take a look at existing methods of monitoring diesel emissions. There's three main methods. One's tailpipe testing. It's a regulatory requirement. It's usually done in a controlled environment, such as a workshop on the surface, getting the engine to the right temperatures and things like that. There's personal monitoring, again, a regulatory requirement. And that sits on your lapel or your collar of your shirt and takes samples of the air as it's breathed in. Unfortunately, it takes probably 2 to 6 weeks. Once the person underground has handed that to the hygienist, it takes 2 to 6 weeks to get a sample back. And that sample will say, yes, you've had an exceedance, or no, you've had an exceedance. And even if it says yes, it doesn't say what part of your 8-hour shift you had that exceedance. And then there's the ambient handheld monitor, which is great for taking underground and doing random checks and getting an understanding of the area. But all of these are random and intermittent and point-in-time validations of the conditions. So with any of those technologies, you're unable to manage your controls. So that's where continuous real-time DPM monitoring comes in. And obviously you're getting a continuous picture of the ambient conditions underground, and you can move in relatively quick time if you see the trends moving to make some alterations. And ultimately the goal is to not get to exceedances. So if you see that trend heading up, you can do something about it before it becomes an exceedance. We recommend that all those technologies are used as in the DPM committee, management committee. All great pieces of information that goes to decision making. We're certainly not saying that Pinssar replaces any of those existing technologies. They are required from a regulatory point of view and do provide some important information. So Pinssar are now across 6 continents and going well globally, mainly in mining, but certainly tunnelling is doing an uptake. So we'll jump to some regulatory support information. Obviously 2012 was when we said the World Health Organization declared it a Group 1. Since then, there's been advancements in tier engines and specific companies lowering their OELs or exposure limits, and then just through, I guess, different periods. This is, I guess, a bit of Australian and English specific. That states in Australia have changed their levels, and then Canada we've got here. But really, the big one that's really starting to change the game is the British standard 6164. So in 2019, they made a revision in that standard. Previously, that standard had not even mentioned DPM, but now it calls for real-time monitoring of DPM. So also in that revision, it also put dust in as continuous monitoring required as well. So previously dust was called on, but not continuous monitoring of dust. So what the UK or the British standards have now done have put those together, and they're saying it shouldn't be one or the other, it should be both. And calling for atmospheric monitoring. So in terms of tunnelling, what that's led to is the project that's currently on there in the UK is the HS2, one of the largest tunnelling projects in the world, and there's four different joint ventures there. As you can see, a lot of the major construction companies from around the world are involved in the HS2 project. And so the clients, HS2, have specified continuous DPM monitoring in their tender documents, and therefore those contractors have obliged to that. And still early days in the project. There's still sort of, I think, only in the first mile of the first of 4 packages, but certainly continuous monitoring of DPM will be a part of all 4 packages. So certainly setting the gold standard for the tunnelling industry worldwide. So we'll run through a case study in tunnelling. This was a joint venture in Europe, under the Mont Blanc in France. You can see the contractors there listed there, again some major players there. So this is in the TELT project, which is a 57-kilometre rail link under the Alps. So the SMP4 scope, which was that joint venture of the first part of this project, consists of 9 kilometres TBM and 3 kilometres of drill and blast. And it was a drill and blast section that they were anticipating they'd produce a higher level of DPM, obviously higher than the TBM, but they felt that this may be higher than what they were required, prepared to handle. Thought it was unreasonable risk to the workers. What they've done prior to that is monitored gases and also the personal monitoring, and also done some dust monitoring as well as weekly airflows, but not done real-time continuous DPM monitoring to date. So they did some research, found Pinssar. The reader was installed in December 28, and they immediately saw some benefits. So they started monitoring for 3 weeks. They averaged 180 micrograms over meter cube. Then they stopped for Christmas for 3 days, and we'll show you a shot of the dashboard next. And then, but the monitor kept monitoring over Christmas break, and that dropped down to 10. So they saw the difference between 180, which is well above sort of the industry standard of 100, down to 10 over that period where they weren't working. So they came back from Christmas, they evaluated the data and the results, and they decided to do an investigation to get a better understanding. Turns out in this instance, middle of winter, under the Mont Blanc, conditions are quite cold, and the operators had turned the ventilation down to become more comfortable, unbeknownst to them what effect that would have on the DPM load. So as I mentioned earlier, it's invisible, tiny particles. The guys turn the vents down. They think they're doing the right thing, but obviously increasing the risk of health problems. So management got that decision reversed. They put the vents back where they should be, and then they monitored again and got it around 50 micrograms. And the guys actually put some coats on to keep warm. So you can see there on the dashboard, this is what we call a dynamic view. You can see those levels prior to Christmas, and then around the 10 during the Christmas break. This shot is what we call a shift average view, and is the one we recommend that operators look at first. So it gives a good indication of trend lines of what your DPM load's doing. And again, you can see either or, you can see the drop at Christmas. So we have a look post Christmas and how that went. You can see once they'd started reviewing and changed the controls, that came back down into their desired level of just under 50. So what they got out of it was I guess for the first time they could understand their DPM levels on a continuous basis. It enabled management to make a decision based on data. They also reviewed their PPE requirements for standard tasks, and also for tasks that they knew would take that limit over, and change their processes and procedures for that. And they actually set some new company OELs around that as well. So that was 2018, and they're still using it today. And that project's about to embark on some significant packages, and another 3 packages there at TELT. So I think 2032 is when they're due for completion of that project. So yeah, still a significant portion to go. Pinssar can also enable other technology such as modelling software such as VentSim and Vuma, and also ventilation companies who are working on, or even individual operations as well, who are looking at ventilation on demand. So they can set up the real-time data from the Pinssar system and adjust their ventilation based on the DPM loads coming through.
Hi everybody, my name is Anthony Bamford. I'm a certified occupational hygienist with past ventilation officer experience, working for GCG Green Consultant Group. Today I want to demonstrate how real-time monitoring, in this case fixed real-time monitoring data, in this case it's Vensim. Vensim is used in mining as a tool to do long-term mine planning, ventilation planning, as well as day-to-day planning for the ventilation network. What you can see here at the moment is a longwall coal mine. The two call-out boxes here are where the Pinssar units are installed. I'll start this model off. So what you're seeing right now is on the right hand side here is the time. So every increment's kind of like a minute, and like I said, it's 1 day's worth of data. So I'll start this model off, and as you can see, the DPM's already spreading through the mine, and it's 20 minutes in to the model. Zooming into a specific area, you can see there's a constant reading of a DPM of 0.04 more or less, and you'll see like there a big spike come through. Could be that a machine has been working upstream of that sensor and maybe just pulling a load, and that DPM plume that it created past that point, and then that will go through the mine right out up to the fans, which is located here. So you can see as it gets closer to the fan, it starts diluting a lot because it mixes in with air that might not have DPM, and also mixes in with higher ventilation flows. Another nice function Vensim has is actually these data boxes. So this specific data box displays the DPM reading in this airway as a live function. So whatever it sees there, it'll display in that data box. Obviously, nice to have if you display this up in a control room or want to show it in presentation somewhere. To change your perspective on how we look at occupational hygiene risk is that we're looking at this in real time or very soon after the exposure occurred, so you can take action. Where currently, where compliance monitoring is very reactive, there's not a lot a mine can do 2 weeks after an exceedance occurred, or it's often very difficult to find out what went wrong. So very handy to try and incorporate this on your sites, and this can be used all over, coal mining, metal mining, tunneling, which I think is a really interesting one to have this in at the moment, as well as if you had buildings, workshops that's got fixed airflow in.
So apologies, I didn't introduce that, but that was just a 3-minute video on Vensim, obviously, by a third-party consultancy group who do operate in New Zealand as well. Yeah, Pinssar don't have any affiliation with Vensim or GCG, so that was an independent video done, just showing how DPM can be used in modelling packages. Other
technologies such as situationally aware smart lighting systems, whereby they're giving a very
visual the wrong slide, yeah,
to operators, users, and workers about the health and safety, as one example, using real-time diesel particulate matter inputs about go, no-go zones within a district. And that's become a really powerful tool, and many customers at the moment are looking to utilize this, sort of updated, latest technology integration of diesel particulate matter with smart lighting systems.
So obviously a good visual there for the operators underground if they shouldn't be going into an area. We've certainly known about the tag board system and its reliability at times. This I guess is a much more visual way to control that underground. So just coming towards the end, and basically just some recaps. Obviously, we're here to support zero harm and tunnelling. certainly struggles at times to get resources, and anything the companies do to improve the conditions will help with efficiency and morale, and certainly with the local community also, and can eliminate risks of shutdowns. We've certainly seen those in Australia due to DPM in tunnelling, where sites have walked off for a number of days because they can smell diesel. Again, not a database decision. This certainly can help take that risk out of the equation. And like I was saying before, if you trend, you hopefully don't get to that point of exceedances. Also, on the flip side, you might find that your DPM load's quite low and doing well, and that may give you the ability to introduce more equipment based on the data. Probably important one. It's the international leading practice for tunnelling in terms of DPM monitoring is the BS 6164. We're sure that other jurisdictions will follow, and certainly the Commonwealth countries would be looking to that BS 6164 as best practice. Thank you for your time this afternoon. We appreciate you jumping on at this late time, and I'll hand back over to Bill and Holly.
Thanks, guys. That was an excellent presentation. We've got a question straight away. So Andy, I had a couple for you up the sleeve, but I couldn't type them out. So Andy has asked, Andy Schmidt, I take it, good work on the real-time monitoring. Is NO or NO2 being looked at also?
So NO and NO2 not in this, not with us. So we went the other way. We just went DPM. So in the past, CO and CO2 of course has been used. NO and NO2 are certainly important, and there are gas monitors doing that, and therefore that should still be part of it. But what we have found is that both of them can be lagging to DPM. DPM, Stephen Hardcastle in Canada did a lot of comparative testing, and what they found is that often the gases were lagging and were not, and couldn't indicate the height at which DPM went. So because the legislation is starting around the 100 micrograms or 0.1 milligram, there was a need they found, and that's, I worked with Stephen for a long time, there was a need, I thought, to actually give the right indication of what the levels were underground for DPM, notwithstanding that, of course, you should still measuring also NO and NO2, which can be indicators too, but they won't tell you how high it's going. So NO will go to a certain height, but you don't know what's the comparative figures in DPM. And so that's where we've been working with Nash and all these people. They've been working with us for a while now, trying to identify DPM and DPM, the mass, rather than, but still, yes, NO and NO2 is very important. You should be measuring it. This, of course, we all know that as the T3s and T4s are coming out, we are getting final particles, but certainly we are seeing an increase in NO2. So yes, it's certainly important to measure too. Okay,
so in other words, you're using this instrument as a proxy for NO and NO2 in the absence of anything specific to measure it. Would that be right?
We don't. NO and NO2 should be measured anyway. That's a compliance. What we do is what we measure is the particles, which gives the management a better idea of the levels of DPMs there are. The NO and NO2 is not just DPM. There are other reasons why you can get NO and NO2. So what we were trying to identify is what's the level of DPM in those figures. So you compare the figures for sure, and they should travel fairly similar. I mean,
yes, that was what I was getting at. Yeah. Okay. No, thank you, Francois, and thanks for the question, Andy. Another question from Samar. He says, how accurate is the instrument in measuring nano diesel particulate matter?
So I think the best way to
answer that is to let you know that we do a calibration, and we do that ex factory. We actually recalibrate the instrument every 5 minutes. So after the 5-minute period, it does an auto zeroing of the technology using the laser light scattering photometry laser. And it brings it back to the new zero, if you like, because there's laser drift, which is always a concern with instrumentation that uses laser light scattering photometry. It's always been a problem. But one of the 23 unique innovations of the Pinssar reader is that we re-zero that constantly every 5 minutes over the life of the reader. We also then do a laser chamber exchange every 12 to 18 months. Now that's a requirement just to really re-ensure that we're getting the most accurate information we can. In terms of its accuracy, what we say is we're a highly accurate trending tool, because you've got to remember, you're talking incredibly small particles. If you miss one particle in a sampling chamber, you may have lost 15–20% of your sample. So therefore, what we say is we take 240 laser shots on each sample, and we take the average of the 240 laser shots, and then over the period of time, you'll find that your trending is very, very accurate. But in terms of each dynamic measurement or figure, there's always going to be that
and hence you look at it over a longer period, as you illustrated in
Definitely,
your...
yeah. And DPM is not something that's going to fall and kill you like a safety issue. So really what you want to understand is over time, what's your trend line? Is it staying the same, going up, or going down? And this is a really great tool for that.
Yeah, cool. So I had a couple of questions, if I may. You talked about, one of the key requirements when you went out and talked to people about what they wanted was low maintenance and reliability. I'll be interested in your typical maintenance regime, especially if there's dust around, you've got to filter that out, so you've got a sampling chamber. So that's question number one. Question number two is, presumably this works on some sort of refractive index, or if you're shining a laser on something. So I'm very interested in what other applications you might have for that technology, given how finely tuned it is. So 2 questions for you, please.
Francois, do you want to jump in on that?
Okay, so
the first one.
So the first one, thanks for the questions, Bill. So the first one, you're correct. So we one of the challenges we had is that at all instrumentation we looked, there were PM 2.5, and that was the intake PM 2.5. So that was a problem because we were bringing a large amount of dust, and anybody that's used to using these instruments will know that that requires maintenance every 3 to 4 days. So what we decided to do is we actually put the sample is taken it with an 800 nanometer cutoff cyclone. So we don't bring any particles larger than 800 nanometers in, and we do that through a cyclone and through a pump that regulates the flow at 2.2 liters per minute. The cyclone is a NIOSH approved cyclone. It's 99.9% accurate. So it's of all the tests we've done in the field, they're very satisfactory. So that is the first thing. So that's how we reduce. When it comes to the maintenance regime, now the maintenance regime with us is actually slightly different to the maintenance regime for dust, because we don't really have we don't have dust. We do have, however, small diesel particles, and so we do recommend that once a month you actually do take there's a small little pot at the bottom end of the cyclone. You empty that. It's a 1-minute job with that, and then every 3 to 6 months, depending on how dirty your environment is. When highlighted that we do have a zeroing facility on this instrument. So the zeroing facility works through and if you can see. So on the right hand side here of the instrument, if you can look, is a metacentric filter. It's a 10 micron metacentric filter, and that actually, and below that there's a 10 nanometer borosilicate filter that brings in totally clean air within the reader and flushes out the whole chamber. That little small filter, probably every 6 months, you might want to check to make sure that it's not dirty. The beauty about a reader is that actually it cannot bring in particles larger than 800 nanometers. So it doesn't bring any dust in, but it may well bring other smaller other particles than diesel in. So we don't find, we say every 6 months, to be honest. Very few people that I know of have changed it. And we go there, and every 12 months, as let's say we have an exchange program, we take the laser out. It's a half an hour to an hour job. Bring a new calibrated laser through the HMI. We'll bring in the new coefficients, and then from there off you go for the next 12 months. Your second question in refraction index is a very interesting one. It's one that we're working quite hard. What we're doing has become possible because lasers are getting better and better and better at doing what they're doing. And the evolutions, we're working currently with Griffith University here in Brisbane to look at other applications for what we're doing. You are correct in saying that each particle has its own particular refraction index, and therefore we should be able to identify the one from the other. At this stage, we've not been successful at doing that. So crystalline silicas is the big one that if we can crack. The beauty about diesel is that diesel always looks the same. Diesel, but a lot of those other particles don't always look the same, and therefore it's slightly more difficult for the laser to identify these particles. We're working it. We believe that by using better lasers, we will actually be able to get there. But we probably, I don't know, it's hard to say, but between two, I think what you'll see in the next 2 to 3 years, it's like once somebody's cracked something, suddenly there's a whole new industry that opens up and people start looking at these other things, and money gets thrown away from research perspective. So we strongly believe that, yes, there will be more applications for this. Pinssar is well aware that diesel isn't around for forever, so that's why we are starting looking at different applications. One big one that we believe is going to be an issue in electric is copper, very small copper particles. Copper particles are below 8 nanometers too, and they will be an issue for almost certain once they get electrification going. So we're starting to now working on that, but that's early days, but that's where we're heading. So small particles will become more and more of an issue once people start to understand, and it's not an issue because we just manage them. Once you know they're there, then you can offer the people the chance to make sure that they don't get confronted. So that's what we are looking. So yes, you are right in your refraction index. I know that you asked the other day on a particular type of particle. We have not looked into that yet, but we certainly it'll be on our radar to look at more specific and other applications to what we're doing.
No, thank you very much for that. Andy Schmidt, I think, again, his real DPM monitoring tells you what you have. Does Pinssar have solutions to reduce filters, remissions, and develop DPM management plans? I think he's looking for a bit of a hand there, Andy. But I presume that you supply this very specific equipment, and that's what you do. I don't want to answer the question for you, but
no, you're right. And then we do have. So we understand we know the controls. There are basically 40 controls that will reduce DPM, and it's free. You can download it from our site. We're quite happy because that's what we want people to do. We want them to start understanding, and it goes from elimination all the way down to PPE. The bulk of them, of course, find themselves in engineering and administrative controls, and that's where we help people, and we often participate here in Queensland. We are participating in a lot of diesel measurement committees. We do participate with the government on diesel forums, and measuring is only one part. It's at least highlighting what's going on. What we are really promoting people is to understand their controls and implement these controls, and then make sure that these controls work in accordance to what they were intending to do. And that's what we are. We often say that we're there as an observer of what's going on. I mean, if I want to be nice, as you say, I'm the cop waiting around the corner to book you if something happens. We like to more believe that with the guys that try to alert you if things change. and don't wait until there are exceedances. Exceedances, I mean, if once you get an exceedance, it's bad news. There's no good news with an exceedance. So we don't ever want to see any exceedances. So we want to try to alert people before they're going to happen. And then we're working in fairly challenging environments. We're working on a development area now on a shotcreting area, trying to identify, because they've had some problems there. We know. So the instrument is robust. It can work in extremely tough environments and still identify issues. So we're hoping within the next 12 months to have a white paper on that. And then basically, but we're always happy to work with people, that's for sure.
Yeah, I think also Daniel's been working with BHP on a TARP as well, a Target Action Response Plan, so that when their DPM levels hit certain levels, there's trigger point reactions to different activities and mitigating actions and responses. So it's not a rolled up perfect mousetrap, because nothing is. It's Pinssar supporting the customer, and we're with BHP all over the globe, including Chile and other places. So it's working with those guys to work out what makes sense for their operations, and everyone's going to be different, but we're happy to support any questions you've got. Obviously, there's going to be links and communication opportunities, and we look forward to welcoming that.
Cool. So you've got a lot of resources on your website, no doubt, and people can contact you via your website if they've got anything to follow up after this, which is great. So I had one comment from a man called David Bellett, who works for WorkSafe, our regulator, and he says, "Fantastic presentation. Can see a future for this in NZ." So there you go. That's pretty useful. And thanks for that comment, Dave. Right, and Andy says also thanks for your response. So
Andy, and thanks,
yeah,
David.
Yeah, all good. Sammy's got a further question, but I think that's been answered actually somewhere, so we'll probably leave that. But the guys can catch up with, or you can catch up with the guys after this presentation. So if there's no more questions from the floor, I think we'll wrap it up there. And thanks again for a very informative and useful presentation. One of the reasons for asking Pinssar to present was to just raise the general awareness of something that probably is uncommon knowledge, and we've all waited for a bit of diesel plant to pass us underground and then walked in quite closely in behind it. I think personally I'm going to leave it a little bit longer now.
Good plan.
The presentation.
That's right.
So thanks very much, gents. Well, look, everybody, thanks for coming along to the session tonight. I appreciate your support. I hope it was useful and informative. We'll look to do more of this. As I said, the next one we were going to do person to person, and we'd still put it online. But we'll probably swap out the NZTS GBR presentation, given we're still likely to be under lockdown. So anyway, watch this space. If you haven't been along to an NZTS event, hope you enjoyed it. You can always consider joining the Tunneling Society, but you're welcome anyway. So thanks again, everyone.